Scientists and engineers, such as us here at Siemens, are investing time and effort to understand non-Newtonian fluid behavior so that we can develop models to capture these complex fluid phenomena. Today, I'm going to show you how to model these fluid behaviors in SimCenter Flowmaster. This schematic shows a number of fluid pipelines. Each one has a different fluid flowing through it, and the associated fluid behavior is captured in the pipe. We can see that this has been set by using the flow consistency coefficient and the flow behavior index, and these are different for each fluid. These are sufficient to capture the pseudoplastic and dilatant behaviors, but if more complex behavior such as being in plastic was required, then the shear stress versus shear rate curve would need to be set. If we look at the results of a study like this, we can see how the flow rates vary depending on the non-Newtonian fluid properties. So blood initially flows very quickly. It exhibits pseudoplastic behavior, which means it is shear thinning. Water has a linear behavior, as it is a Newtonian fluid. And the applesauce shows the opposite behavior, as it is a dilatant fluid, meaning that it initially resists the flow and then suddenly starts to flow quickly. We can now look at a slightly more complex example. To do this, we can use the concrete pumping truck, which is included in the sample systems that are built into SimCenter Flowmaster. This example represents a reservoir that concrete is poured into. It then has 4 cylinders and a series of check valves that drive the flow through the piping. This is all contained within the concrete pumping truck. The concrete slurry is then pushed through a series of concertinaed pipes in an arm that is used to deliver the concrete across a construction site. When this simulation is run, we can see how the fluid behavior affects the simulation. We can see how the fluid is drawn into each of the cylinders and then pushed out. This is the main driver of the fluid flow, as concrete is difficult to move around due to its non-Newtonian characteristics. We can see how the fluid flows through the pipework and then out through the arm. If we look at the results of this, we can see the flow rate through this delivery arm and how it has a lagged response due to the design of the piston pump. The other thing that is important to note is the pressure at the node level in the arm, and this never drops below 2 bar, meaning that the pressure is sufficient to deliver the concrete slurry. A lot more information on how to use these components and the physics behind them is contained within the reference help documentation, and also in the sample system document that explains both of these systems in much greater depth. To sum up, we have shown the new non-Newtonian physics in SimCenter Flowmaster, and how it can be used to capture complex fluid phenomena that materials such as concrete slurry or applesauce exhibit. Thank you for watching. For more information, please visit our website.